respected class in charge, and my dear friend. Firstly, very great morning to all of you.
Very great morning, Lavish.
My name is Lavish. I study in 12th Science Standard. Today, I am here to play a role as a teacher. So, today our topic is atom as a magnetic dipole. So, friend, first of all, we know that what is magnetic dipole? An arrangement of two poles of equal and opposite strength separated by a fixed distance is known as magnetic dipole. Our topic is atom as a magnetic dipole, means atom act as a magnetic dipole. So we prove that atom act as a magnetic dipole. If atom act as a magnetic dipole, then definitely magnetic dipole moment of an atom is associated with it. Then we find the magnetic dipole moment of atom also. Firstly, as we know that in an atom, electrons are present and electrons are present in the circular orbit. Electrons are revolving continuously in circular orbit as you can see in this figure. Friend, as we know that mass of electron is, we denote it here m, and its value is 9.1 into 10 raised to power minus 31 kg. Here, because radius of circular orbit is small r. Radius of circular orbit is denoted by small r, means distance from this positive charge to electron, or we can say radius of circular orbit is denoted by small r. Then velocity, uniform velocity with which electron revolving in the circular orbit, we denote it by small v. So now we find, as we know that angular momentum, we denote angular momentum by capital L, and magnitude of angular momentum is mvr. We give this equation 1, and now we know that time period. What is time period? Time taken by electron to complete one revolution is known as time period, and we denote it by capital T, and T is equal to 2 pi r by v. How this comes? As we know that velocity is always equal to distance upon time, or speed is always equal to distance upon time, and time is distance upon speed. Here electron is revolving with uniform velocity v, and circumference of a circular orbit is 2 pi r, hence our time period comes T is equal to 2 pi r. Now charge on electron. Charge of electron is minus E. Minus sign here shows that value of E is 1.6 into 10 raised to power minus 19 coulomb. Here magnetic sign shows the just direction, but here we take magnitude of charge of electron, that is only E. And now we find the current. As we know that, but we know current is equal to rate of flow of electron, means Q upon T. Here Q is equal to E, we take magnitude, and T is equal to 2 pi r upon V, hence 2 pi r V. This is our current, means I. Now we find magnetic dipole moment. Magnetic dipole moment is denoted by capital M, as you can show here, see here, and magnetic dipole moment M is equal to I into A. So for finding magnetic dipole moment, we also calculate area of circular orbit. What is the area of circular orbit? That is pi r square. From this current and area, we can calculate the magnetic dipole moment. Magnetic dipole moment. Magnetic dipole moment is equal to product of current and area of the circular orbit. We find both current and. So friend, magnetic dipole moment. Magnetic dipole moment is product of current and area of the circular orbit. Now from here we find current as well as and area also. We put this value in this equation. We name it as equation 2, and we get EVR upon 12 upon 2. Here we multiply and divide by m. Why we do this? Because we find relation between magnetic dipole moment and L. L is the angular momentum. So this, as we know that angular momentum is MVR. This is our first equation as we discussed. And from here, magnetic dipole moment is equal to EL divided by 2m. If we write this in vector form, we get m is equal to minus E L, and this symbol show vector means here magnetic. So friends, magnetic dipole moment, it is denoted by m, and m is equal to Ia. We find value of I also, A also, we put it here, and we get EVR upon 2. And we multiply and divide by m to get relation of angular momentum with magnetic dipole moment. And from here we get magnetic dipole moment is equal to EL divided by 2m. Here L is angular momentum and L is equal to MVR. In vector form we get this equation. Here we write negative. What this implies? This implies that angular momentum and magnetic dipole moment are in opposite directions. So friends, this is all from my side. Thank you and have a